Okay, we're going to talk about proving that lines have a constant rate of change. Now, it's pretty simple to see that if you build something from the ground up as a line, and you say I'm going to repeatedly add the same number for every one that I go in my input, I'm going to go up by the same amount. It's easy to see that it will always end up on the same line. But we want to be able to say that for any points on a line, so this difference, this rate of change is the same as if I took, this big difference in this rate of change of any 2 points. So the way that you can say that is the rise over the run, or the change in the function value over the change in the input value. We'll call that A as the change in the function value, and B as the change in the input value. And then on this, the difference in these 2 points, we'll call this the change in the function value C, and this the change in the input value D. So we want to say that this is the same rate of change. So A over B is equal to C over D. This is what we want to show. Okay. So if you've taken mathematical thinking with us, or in any 8th grade standard, you learn about transformations, and that when you do a dilation, or actually when you do a translation, you slide something. So if I trace this and slit it up, this angle would map directly on top of this angle, right, if I slide that up. So I know those angles are the same, and then this, by definition, because it's a vertical and a horizontal, have to be perpendicular, so this angle will be the same. So we say this triangle, we'll call it triangle N, and this we'll call triangle M. So triangle N is similar to triangle M by angle. So if 2 angles are the same, the third has to be the same, because they have to add up to 180. But so we know that those 2 triangles are similar, and if those 2 triangles are similar, that means their sides are constant multiples of each other. So we could say, well, A is equal to some constant K times C. Right, if this is A and this is C. And then also B would be a constant multiple of D. B is a constant multiple of D. So then A divided by B is the same as KC divided by KD. And then since any number divided by itself is just equal to 1, then that must also be equal to CD. So that was what we were trying to show. So that checks out, and our proof is complete.